route filtering. Do you have any idea about route filtering?
Yes, so route filtering is the process of manipulating routes in the routing table. So, for example, if you have a route summarized, but you need a specific route to also be installed in the routing table, you can use route filtering to edit, or if you want a specific route not to be included in the routing table, then you can use methods of route filtering to exclude it.
And how we can configure route filtering?
You can use like route maps, a distribution list. What other method in EIGRP? Like that one we did the leak map. An access list, stuff like that.
All right. Okay. So you have the idea of route filtering. We just have to do a quick session about it. Okay.
Yes.
So as you know that EIGRP is a dynamic routing protocol.
Yes.
R1, R2, R3. /30, /30, /30, and /30. So for example, if R1 is having prefixes in its routing table, or for example, directly connected with R1, to 10.1.1.0 to 10.1.5.0. All right.
Yes. Yes.
So now if we talk about EIGRP, OSPF, or BGP, all right, all of these protocols are working on a model known as push model. We have another model which is known as
pull model.
Pull model. So pull model is used in a protocol which is known as Lisp. Do you know something about Lisp?
Yes, location identity separator protocol.
Locator ID separation.
Yeah, we use it on mostly on SDA. So it's quite new.
We use it when?
For software-defined access networks. Yes, to build it.
And mostly it was introduced for global internet routing tables.
Okay.
But when we have introduced SD access in our networks, so we have started using Lisp as well. All right.
Yes. Yes.
So nowadays we are also using Lisp in our enterprise network. But initially Lisp was developed for ISP networks. All right.
ISP. Okay.
But if we talk about EIGRP, OSPF, or ISIS, or BGP, all of these protocols are working on the push model.
Okay.
What do you mean by push model? The push model is very simple. Whenever two routers will become neighbors of each other, they will be advertising prefixes by sending an update message to the neighbor. Right?
Yes.
Whenever two routers will become neighbors of each other, they'll be advertising the prefixes by sending an update message to
each other.
Right? You are not asking the neighbor, or you are not believing that, okay, if in case that router will need prefixes, it can ask to me. No. The simple behavior is push model. It means whenever you will advertise these prefixes in EIGRP, right?
Okay. Yes.
So what R1 will do? R1 will advertise all of the prefixes to R2.
R2.
Likewise, what R2 will do? R2 will advertise these prefixes to R3.
3.
What R2 will do now? R2 will say that for me, next stop is 12.1.1.1. And for R3, next stop is
23.1.1.1.
Right. So now this is known as push mode. The problem is because of this behavior, the router might be receiving unwanted prefixes from a
neighbor.
And it may be advertising unnecessary prefixes to
the neighbor. Okay.
To a neighbor, right? There are two cases. Either you are receiving unwanted prefixes or either you are advertising unnecessary prefixes. So because of this behavior, a route might be receiving unwanted prefixes from a neighboring router and it may be advertising unnecessary prefixes to the neighbor, right?
Yes.
So each routing protocol supports some sort of route filter to discard unnecessary prefixes. So each routing protocol supports some sort of
route
filtering to discard unwanted prefixes, right? In EIGRP, OSPF, BGP, or ISIS, you can configure route filtering for incoming and outgoing updates both. All right. So whether it is EIGRP, OSPF, BGP, or ISIS, you can configure
incoming outgoing updates
for incoming and
outgoing updates
both, right? But you will see that OSPF is having few while configuring route because you know that behavior of OSPF is link state. So in case of OSPF, you cannot filter LSA1 and LSA2. Right?
Yes.
So if you want to configure route filtering in OSPF, you have two options. Either you can configure route filtering on ABR router or you can configure it on ASPR. Right?
Yes.
Yeah. Lisp. Basically, we are not talking about Lisp here, but in case of Lisp, we have something known as concept of map server, and map resolver. So we have a map resolver and we have a map server. So basically, if this R1 and this is R2, so both of them will be having a ID, which is known as rlog.
Yes.
This is known as
rlog.
For example, we have any underlay network here. All right.
Yes.
So now, what they will do if R1 is having a network 10.1.1.0/24 and R2 is having a network 20.1.1.0/24. Instead of advertising prefix to each other, what they will do, they will advertise the prefixes to map server.
Map server.
1.1.1 is the RLOC for which network 10.1.1.0/24. In case of R2, R2 will also advertise it to the map server that 20.1.1.0/24 network is connected with. To reach, you can forward traffic to 2.2.2.2.
Okay.
If in case if R2 wants to reach 10.1.1.0/24, first of all, R2 will go to its
map resolver.
Map resolver. And map resolver will provide the information of routing locator. So mostly Lisp is used in
underlay.
Or we can say to create the overlay network. So basically, yeah, we can say overlay network. So it is used in overlay network for control plane.
Okay.
In SDXS, and we use in overlay network data plane. So in overlay network, we have two planes, control plane and data plane. So for control plane, Lisp is there, and for data plane, VXLAN is there.
Yes.
All right. So you have two options. Either you can have this for control plane, and for data plane we have the VXLAN. This is a completely separate topic. All right, let's come back to our topic. So in case of EIGRP, we have to configure the filtering. All right. So now, if R1 is advertising prefixes to R2, you can configure the route filtering at 2 points. Either you can configure route filtering on R1, all right? Which direction? Out direction. But if you haven't configured route filtering on R1, you can configure route filtering on
inbound.
R2, right? Inbound, but you can say for indirect.
Yes.
We have two directions to configure route filtering in EIGRP. First is out direction and second is indirect. So in EIGRP, we use a concept of distribute list. All right.
Yes.
So basically, this is the routing table of R1, for example. Whenever you will advertise these prefixes into EIGRP, what EIGRP will do? First of all, EIGRP will install all of these prefixes in the topology table. Yes or no?
Yes, it will.
R1 will install all of the prefixes in the topology table. Then R1 will calculate FD value and RD value. R1 will calculate FD value and RD value. So basically, the distribute list is here. Distribute list is located here. Distribute list. Okay. Yes. So whenever R1 will build an update message, first of all, it will pass through it to the distribute list, and then we will have the final update. All right. Yes. If you have applied the distribute list in out direction, all right. Yes. And if you also applied the distribute list for the in direction, so what will happen whenever R2 will give an update message to R1? that update message will pass through the
distribute list first.
And then the prefixes will be installed in the routing table. So by default, there is no prefix list. That's why we always see that if you are advertising a prefix to the neighbor, you will see it in the routing table of your neighboring router. But if your neighbor is advertising a prefix, you will see that prefix in your own topology table. All right.
Yeah.
Because by default, we haven't configured any distribute list. All right.
Yes, sir.
So this is update message going to from R1, from R2 to R1. And then R1 is advertising an update message. So if R1 wants to advertise all of these prefixes, but I've configured a distribute list. And in distribute list, I have said that you have to deny. All right. So when the final update will come out, you will see that in this update message, this prefix is missing.
Okay. Yeah.
This prefix is missing. Okay.
Yes.
So this is how the distribute list works. Now, so basically the distribute list is something which is used to control that what we are distributing, right?
Yes.
So distribute list can take decision on the basis of, like I said, access list. It can take the decision basis on the
prefix list.
And it can take the decision on the basis of
route map.
And in access list, we can have two type of access list.
Standard and extended.
Standard and extended AC. We don't have any such thing in prefix list in our route map. All right.
Yes.
So remember that in standard ACL, you have 1 to 99 and 100 to 199. Then, do you know what is the difference between access list and prefix list?
So I can say with the access list, we can specify source and destination. And then with the prefix list, we use the prefix or the IP of that we want to filter.
Okay.
I'm not sure if it's a complete definition.
All right.
And I think maybe prefix lists are more flexible than the access list.
Yes, you are right. So basically, prefix list is specifically designed for route filtering or to match a prefix.
Yes.
But access list is designed for, like you can say, 100 of operations. Like if you want to filter out traffic, you can configure an access list. If you want to configure quality of service, you have to configure an access list. If you want to configure NAT, you have to configure an access list. All right.
Yes.
In an access list, we have, you can say we have many attributes to match. Like we can match protocol, we can match the source port, we can match the destination port, we can match the message type, right? But the prefix list is mainly designed to match a prefix only. You can match a range of prefixes. You can match range of subnet mask as well. So we will discuss it. And then route map. So basically route map is not designed for route filtering, right?
Yes.
We can use it into route filtering. But in case of route map, you will see that route map can perform two operations: match and set. But if you see any other attribute like access list or prefix list, they can match a prefix, but they cannot set something.
Okay.
All right. Yeah.
Okay.
So here we can match and we can set values as well, right? So let's go to event. Let's see it practically. So close lab. I'll tell you that why I have added a switch between VIS2, VIS3 and VIS1. Okay.
Yes.
Let's remove this link. This is the topology. So let's start with devices. Forty-four 1.1.0/24. So what will happen here? From R4, we will advertise this prefix to R2 and R3, and R2 will advertise this prefix to R1, and R3 will also advertise this prefix to R1. All right.
Yes.
We will also create some loopbacks on this router as well, but later on we'll see it. Okay.
Okay.
And the subnet we will using here is 123. Okay.
Okay.
24.1, 24.2, 34.1, 34.2. So first of all, let's go to VIS1.
Sorry, Amit, can I ask what program are you using to write like on this if?
What?
The program you use to write for on your if?
It is known as Epic Pen.
Epic Pen. Okay.
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 Yeah.
Thanks.
Welcome. is VLS1, VLS2, VLS3, and VLS4. Host to IP interface based exclude unassign. On this interface, IP address is 12.1, but we are going to change it to
123.
123.1.1. Now we'll go to VIS2. Configuration mode interface gigabit 0/0 IP address is 123.1.1.2. No shutdown. Gigabit 0/1 IP address is 24.1.1.1. No shutdown.
Okay.
Host to IP interface brief exclude. All right.
Yes.
Now let's go to R3. Configuration mode. Interface gigabit 0/2. No shutdown. IP address is 123.1.1.3. Interface gigabit 0/1. No shutdown. IP address is 34.1.1.1. Show IP interface BFX unlisted. Up is also having an extra interface right now, which is 0/0. We can do it shut down and we can say no IP address.
Okay.
Then we have the iOS4. Interface gigabit 0/1. No shutdown. IP address is 24.1.1.2/24. Gigabit 0/0. No shutdown. IP address is
34.
34.1.1. So the interface brief exclude. And you can see that R1 is having loopbacks as well, right?
Yes.
The loopbacks on R. First, we'll go to R1. I'll say no router EIGRP 100. I'll go to R2. I'll say no router EIGRP 100 because I want to run it from scratch.
Okay.
No router EIGRP 100. And the iOS. No router EIGRP 100. Right. Let's go to the iOS1 and enable EIGRP. Router EIGRP 100. Then choose IP interface brief exclude unassigned. R1 is having total 5 loopbacks and 1 physical interface. I'll say network. Then I'll go to router IGRP 100 network and network 24.1.1.0. Then I'll go to VIS 3. Router IGRP 100 network 123.1.1.0 and network 34.1. All right.
Yes.
And last but not the least is R4. Let's configure EIGRP and R4 as well. Router EIGRP 100. So you can see here, so IP interface brief. As of now, R4 is having 2 physical interfaces and 3 loopbacks, right?
Yes.
So network 24.1.1.0, network 34.1.1.0, and network
40.1.1.
40.1.1. Now if I see show IP EIGRP neighbor, R1 is having 40, 2 neighbors, R4, sorry, right?
Yes.
And if we see the prefixes here, show IP route EIGRP, R4 is receiving loopbacks of R1, right? And what R4 is doing this time, R4 is performing load balancing.
Yes.
Because if you see in the topology, in order to reach loopbacks of R1 is having 2 paths, right? Via R2 and via R3.
Yes.
Both of the routes are having equal
metric.
Because of equal metric, R4 is having 2 successor routes to reach loopbacks of R1. We can see it as show IP IGRP topology. If you see here, you can see that 10.1.1.4/32. How many successors are there?
2 successors.
2 successors. 2 successors. 2 successors. 2 successors. Right? So R4 is having 2 successor route to reach the loopback of R1. Now we are going to configure the route filter. All right.
Yes.
The very first example is that we don't want to receive this prefix 10.1.1. We don't want to receive 10.1.1.2 prefix from any of the neighbors.
Yes.
I don't want to receive this prefix from any of the neighboring routes. All right.
Yes.
So what I'll do here, first of all, by using access list.
Okay.
IP access list standard 10. I say
Yes.
10.1.1.2. Because this is the wildcard mask for a prefix, which is advertised at /32.
32.
Then I'll go to router IGRP 100, right? I'll say distribute list.
Yes.
After distribute list, it is giving you an option of access list. For an access list, I've configured access list 10. Then you have 2 directions. So R4 is receiving the prefixes, right?
Yes.
R4 is not advertising that prefix.
Yeah, so it's in.
So the direction is
in.
After in direction, we are getting an option to mention the interface number as well.
Okay.
So in this topology, R4 is receiving update messages on 2 interfaces. On this interface, right? Hello.
And so that's what?
This interface. So if you will not mention the interface number here, distribute list will be applied on both of the interfaces.
Okay.
All right. This is the default role of distribute list. So if you're not going to mention the interface number, distribute list will be applied to all the interfaces. All right.
Yes.
But for example, if you have R5 as well, R5 is also connected with this. So now you're receiving update on 3 interfaces, right? And you want to apply the distribute list only on this interface and this interface. So in that case, you have to mention the interface name.
Okay.
Right.
Yes, understood.
You can give the interface name if you want gigabit 0/0.
Or you can do a range also. Okay.
So 0/0 and 0/1. So it is not allowing us to give a range. So we have that keyword. No. So we have to give the individual interfaces. Okay.
Okay.
Yes. So I'll say simple end.
Okay.
So let me show you the default scenario. Let me remove it for once. I've removed the distribute list. Okay. So you can see here, so IP properties. You can see these 2 lines.
Yes.
Give it a hit.
It's not set. Outgoing updates filter list for all interfaces is not set. Incoming and outgoing.
Right?
Yes.
So now you can see that by default, outgoing update filter list for all interfaces is not set. Incoming update filter for all interfaces is not set. Now we will make the configuration. Router IGRP 100, distribute list 10 in. Now you will see that show IP IGRP name. Show IP. You can see here.
Yeah.
Is there any prefix of R1 now? Any
No.
of the loopback? No, right?
No prefix. Yeah.
We want to filter this loopback only 10.1.1.2, right?
Yeah.
But now you can see that none of the prefix is present in the routing table.
Yeah.
Because of implicit deny rule, right?
Yeah. Okay.
Please make sure that you don't forget to enter the permit any command at last.
Yes.
Because in access list, we have a rule of implicit deny.
Deny at the end, yeah.
I have did this thing intentionally, okay, so that
we can see, we can remember.
Yeah. So now if we'll see so IP access list, I have 2 statements here, right? And if I say so IP route, in this you can see which prefix is missing right now.
Yes, you can see 4.
10.1.1.2 is missing, okay? Or you can also do the same thing on R1, but for when you configure it on R1, you have to do it in the out direction.
Yes.
So if I say configuration mode, IP access list standard 10, I say deny 10.1.1. For example 3. All right. Then I say permit. Router EIGRP 100 distribute list 10 out. So then pipe section access. Okay, we already have that access list. Okay. Remove that entry. Okay. There was an access list. Was permitting 10.1.1. Now you can see that we have only two statements. One is denying 10.1.3 and second is permitting everything else. Okay. Now if you see show run pipe section access list. Exit. Okay. Router EIGRP, whatever the AS number, distribute list, access list, in or out direction, and
Yes.
the interface number. And then exit. All right. Sorry.
Okay.
So always remember that this thing is
Optional.
mandatory. Okay. You have to define the direction in or out, but the interface number is an optional thing. It is your choice. You can give an interface number or you can't, right?
Okay.
This is how you can use the standard ACL to filter the prefixes in EIGRP. Now, if you'll see that if you have done this thing on R1, now you will see that that particular prefix is so IP route EIGRP. You cannot see 10.1.1.3 here. All right.
Yes.
Now you'll see that we have filtered 10.1.1.2, but it is still there. We have filtered 10.1.1.2 on R3. Okay.
Yes.
Not on R2.
Not on R2, yes.
Yeah. But we have filtered R3 on R1. We have filtered R10.1.1.3 on the originating router.
Yes.
So now you are not able to see it on R2, R3, or R4, any of them. Okay.
Any of the neighbors, yes.
Yeah. So this is how you can use the access list to filter the prefixes.
Okay.
Please, but let me note it down here for you. Please now forward to override implicit deny rule and access list. Please don't forget to override the implicit denier rule of an access list. Okay. For that, you know what you have to do. You have to say permit any.
Any, yes.
Go to R4. Router IGRP 100. No IP access list standard. So I have removed the distribute list and I have removed the access list. All right. I'll go to R1. No IP access list. Standard. Now you'll see that standard list is enough to filter the prefixes, right? Is there any use cases of extended ACL in route filtering?
No. Let me think about it.
But we can use it. Okay.
Okay. Yeah.
See, we see in this case, if what I want that R4 should not receive 10.1.1.0/24 prefix from R. I can configure an access list, then I'll configure a distribute list, and I'll apply that distribute list on which interface.
Okay.
Right. So R4 would not be able to receive that prefix from R2, but it can receive it from R3. Because R2 and R3 are sending update message on two different interfaces. But for example, if I say that prefix loopback of R4 is going to R1 and R3. What I want now on R1, I want that R1 should not receive 40.1.1./24 via R3. Now this is not possible. If I'll apply an access list on this interface for indirection, prefix will be filtered from VIS2 and VIS3 both, because both of them are sending an update. But for R3, R1, the update is coming to the same interface. Yes or no?
Yes, yes.
Right. So if you want to filter the prefix from a particular neighbor, in that case, you can use which ACL?
The extended.
Extended ACL. All right. Now, the question is, extended ACL can match source and
destination.
This is right. But this time we are not configuring extended ACL for traffic filtering. We want to configure extended ACL for route filtering, right?
Route filtering, yeah.
So if we see here, when R1 will send an update message, what R2 will do? R2 will say that this is EIGRP update. Source IPs and destination IPs. And in this update, we have its prefix. We have the prefix 40.1.1.0/20. And when R3 will give an update message, this is the update packet. In update packet, we have the prefix 40.1.1.0/24. The source IPs. Sorry, 123.1.1.3, 224.0.0.10. So when you configure access list on VIS1, which access list? Extended access list. Extended ACL. Source IP address will match the source IP of an update packet. All right. Because while you configure an extended ACL,
source IP address
ACL, in that case, in extended ACL, you have to define two things. You have to define source IP address and you have to define destination IP address, right?
Yeah.
Then we define source IP address. The source IP address is going to match the source IP of update message. So you can see that R1 is receiving 2 updates from different source IPs.
Yes. Okay.
Right? So let's see it practically. Okay.
Yes.
So let's go to VLSM. Show IP about EIGRP. You can see that R1 is receiving prefix of 40.1.1.1, 40.1.1.2, and 40.1.1.3 from both the neighbors.
Yeah.
123.1.1.2 and 123.1.1.1. Right? Now, if we go to VIVS1 and we see that IP access list standard, extended 101, deny. You have to give the protocol, so you have to say IP. So you have to define source. You can say any. If you'll say any, in that case, it will match 123.1.1.2 as well as 123.1.1.3.
Okay.
Right. So we have to specify the IP address of update message. So it is going to be 123.1.1.3. We want to filter it from 3.
Okay.
Then you have to define the destination address. Destination address is going to be 40.1.1.1 and wildcard mask is for a single IP address, right?
Okay. Yes.
And you'll say permit IP any. Because this time permit any is not enough. You have to give permit IP any source and any destination. Then router EIGRP distribute list which direction, right? Now you can say the interface number, and this is not going to make any sense here because R1 is having only one interface.
Yeah.
Distribute list 101 indirects. Now let's wait for seconds. Now see, show IP access, show IP access list, yes. So you can see we have 2 matches here. Then we'll see show IP route EIGRP. So you can see 40.1.1.1 is still present in the routing table.
Yes.
But from 123.1.1.2. Not from 123.1.1.3.
Yes.
उधर ही गए हैं, उस तरफ ही गए हैं. Router EIGRP 100 distribute list 101 in that.
रिप्लाई नहीं कर रहा व्हाट्सएप पे मेरे पास में फोन होगा रिप्लाई नहीं कर रहा उसको बोल रिप्लाई करे रिप्लाई नहीं कर रहा
So you can see here this 123.1.1.3 is matching the source IP of update packet. All right.
Yes.
And this is the destination IP address, which is matching the
Advertisement.
advertised in
Update.
update message. Right.
तो देखिए कि 3-4 में मॉक टेस्ट हुआ है जॉब वालों ने भी 5-6 लोग उन्होंने मुझे भेजा ना तो मैंने शीट में डाल दिया कल भेजा था उन्होंने मुझे वो शीट ना उसमें है जिसमें सीसीएम और मॉक टेस्ट वगैरह के तो उसके नीचे ही बनी हुई है जो आप क्वेरी करनी है
So this is how we can filter the prefixes using the access list,
आपको शेयर नहीं है
which we can configure standard ACL and extended ACL. All right. Then second we can have
Prefix list.
prefix list. Do you have any confusion in access list?
No. Exactly.
Now, what is the difference between access list and prefix list?
Yeah. So we said access list. We have options of using source destination, the IP, and the
Yes.
ports. Yeah. Prefix. We use the prefix option.
Now, if I go to R1, and if I remove everything from R1,
Okay.
and I get no access list. 101. So show IP access list. And we can say show IP route EIGRP. Now R1 is receiving all the prefixes, right?
Okay. Yes.
And R1 is receiving all the loopbacks of R1, right?
Yeah.
Now I'll go to R1 and what I'll say, I'll change the IP addresses of the loopback addresses. Show IP interface brief exclude message. See the first thing, I have removed all the loopbacks.
Yes.
Now I'll configure loopback one first. I'll say 10.1.1.1 /20. All right.
Yes.
So loopback 10.1.1.2. 2.1 and 25.
Okay.
I'll configure loopback 3. Ten dot 1.3.1 190 means 26.
26.
Loopback 4. Two to 4.
Yeah.
Means 27.
Plus 27.
Five. 2 4. It is 20. And interface loopback 6. IP address is 10.1.6.1. Interface loopback 7. So IP interface. Now R1 is having 7 loopbacks. So those two IP EIGRP interfaces all of the loopbacks are advertised in EIGRP, right? You'll say that we haven't advertised the prefixes. They are advertised because of this command, because we have advertised network 10.1.1.0. So the parent network is same for all the loopbacks, right?
Yes.
Because as you can see, that first two octets are same.
Same, yes.
So now if I go to let's go to R. So IP route EIGRP. You can see R4 is receiving the prefixes 24, 25, 26, 27, 28, 29, and 30. All right.
Yes.
For example, I want to filter this, and this. I want to filter 4 prefixes.
Yes.
So if I go to configure an access list, what I have to do? I have to configure an access list like this.
For individual.
Standard 10. You'll say deny 10.1.3.0 26. So for 26 0.0.0 126 means 192, right?
Yeah.
In case of 192 minus 255 is going to be
191.
Because we have to minus it from this 255.255.255.255 255.255.55.192.
192. Yes.
So 3 15 minus 9.
Yes.
63. 63. Deny 10.1.4.0.0.0.27. In case of 27, it is 2, 4, 2 to 4.
2 to 4.
So it is going to be 30. Deny 10.1.5.0. 28. 28 means 240. So it is going to be 16.
16.
Sorry, 15.
15.
Deny 10.1.6.0. 29. 0.0.0.7. And permit N. Right?
Yes.
So access list cannot match
range, right?
range of
Prefix.
prefix length, or you can say subnet list. All right.
Yes.
We can access list cannot match
Prefix list.
range of prefix list. Okay.
Mhm.
Yes. So for this, we can configure the prefix list here. All right.
Mhm.
But we can't finish it today because I have another class in next 10 minutes. All right.
Okay.
So in next session, we will discuss that how the prefix list works. Okay.
Okay, no problem. Thank you.
And I'll upload the videos today. Please remind me on WhatsApp.
Okay, I'll do that.
So have a good day.
Have a